Namaskaram everyone and welcome to the Telangana Model School Junior Inter webinars. Dear students, today you're going to have webinar session on Mathematics 1A followed by 3 more subjects, Physics, English and Economics. To begin the day, we have session on Mathematics 1A from Trigonometry. Dear students, you have already tasted trigonometry with introduction, with compound angles, multiple and submultiple angles. Now, to continue that flavor, to solve few more problems on multiple and submultiple angles, as well as to teach you sum and difference of transformations of angles, ratios of trigonometry, we have with us the popular and very passionate teacher, PGT Mathematics, Mrs. V.USHA from TSMS Velimala, Arsipuram Mandal, Sangareddy district, to begin the day for you today. Usha madam, the session is all yours. Please go ahead.
Thank you, madam. Having said that, I feel that the students have liked the taste of trigonometry, right? We'll go ahead with this concept. As I was mentioning, trigonometry will not leave you throughout your intermediate. Yesterday, when you have seen 1B topic in pair of straight lines, hope you have recollected the compound angles in trigonometry, right? Sir was using cos of a plus b, sin of a plus b format in solving or in proving the theorems, isn't it? So trigonometry, it plays a vital role in the total of your intermediate syllabus, children. And that's the reason why I say you start liking it, okay? And keep practicing. Right. Today, we'll do some problems relating multiple angles and submultiple angles. Then we'll go with sum and product of transformations and the application of sum and product of transformations. We'll start with a problem with multiple and submultiple angles concept, children, and also compound angles. See, when we start problems in trigonometry, the problems will not confine only to certain formula, like only multiple angles, only submultiple angles, only compound angles. We keep on using all the different concepts what we have seen right from the beginning. That you will come to know in a few minutes when we start solving the problems. Let us start with prove that sine A, sine of pi by 3 plus A into sine of pi by 3 minus A, pi by 3, 180 by 3, which is equal to 60. Okay, this is equal to 1 by 4 sine 3A. And we need to deduce that sine 20, sine 40, sine 60, sine 80. When you multiply, the product will be 3 by 16. Okay, children. Now, just try to observe what is given to you in the question. You need to prove the first part. Second part, you are deducing. What is the meaning of this deducing? After proving a statement, we will make use of the statement and we will try to get the solution for the second part. That is deducing. That means you need not prove again for this part also. Okay. So let us take the LHS of the statement, children. Sine A, sine 60 plus A, sine 60 minus A. Right. Now, just to see the last two terms, this is looking like sine of A plus B into sine of A minus B. By this time, I'm sure that you are very good at the formulae, right? So what is sine of a plus b into sine of a minus b? Try to recollect the formula. It is sine square a minus sine square b. Now here the value of a is 60 and the value of b is a over here in this statement, right? So we will take it as sine a into sine square pi by 3 minus sine square a. See children, just to make you familiar with the values, I am trying to use in the degree format and also the radian format. Here I have taken it as pi by 3. Don't get confused when I say it is 60 degrees. Okay, 60 and pi by 3 both mean the same. Right. So having said that, let us continue. Sine A into sine 60 is root 3 by 2. Root 3 by 2 whole square will be 3 by 4 minus sine square A. Now take the LCM in the bracket part, then it will be 4 as your LCM. Then if you simplify, you will get it as sine A into 3 minus 4 sine square A by 4. Now just multiply sine A with these terms, children. Then you will have it as 3 sine A minus 4 sine cube A divided by 4. Now we have seen multiple angles in the previous session. And when I was mentioning that, I have given certain formulae for sine 3a, cos 3a, and so on. Now, if you look at your numerator part, the numerator is 3 sine a minus 4 sine cube a, which is nothing but sine 3a. Therefore, we can write this as 1 by 4 into sine 3a. All right. Then the statement what we have proved is sine a into sine 60 plus a, sine 60 minus a is equal to 1 by 4 sine 3a. Now, the first part of the problem is done. Then what is the second part? He's asking you to deduce. What you need to deduce? You need to deduce a statement, right? So to deduce that statement, the question is sine 20, sine 40, sine 60, sine 80. Now, if you just observe, 60 plus 20 gives you 80, 60 minus 20 gives you 40. And that means if I take A as 20, then you can see certain terms which are there in the deduction part, right? So you have it as, we will just take A is equal to 20 degrees. And we'll just substitute in this equation what we have proved just now. Then we'll get it as sine 20, sine 60 plus 20, sine 60 minus 20, which is equal to 1 by 4 into sine 3 into 20. 3 into 20, which gives you 60, right? So what is that you have here, children? Sine 20 you have, sine 80 you have, sine 40 you have, isn't it? But what is missing? Something is missing over here, that is sine 60. So we will multiply with sine 60 on both sides. Then we'll have it as sine 20, sine 40, sine 80, sine 60 is equal to 1 by 4 into sine 60 you have already, and another 60 degrees, sine 60 degrees we are multiplying on both sides, right? Then we'll have it as, look at this, sine 20, sine 40, sine 60, sine 80 is equal to 1 by 4 into sine square 60 degrees. What is sine 60? Just now we have seen, right? It is root 3 by 2. So root 3 by 2 into root 3 by 2, which gives you 3 by 4 into 2 into 2, which leaves the answer as 16. So it is 3 by 16. Therefore, we can conclude saying that sine 20, sine 40, sine 60 and sine 80 degrees is equal to 3 by 16. Now, if you can observe in this deducing part, did we prove it in the literal sense, like how we have proved the statement? No. We made use of the proof what we have taken in the first part of the problem and we tried to deduce it. Right. We'll look into another concept. If A, B, C are non-zero real numbers and alpha comma beta are solutions of the equation a cos theta plus b sin theta plus c equal to 0, then we need to show that sin alpha plus sin beta is equal to 2bc by a square plus b square, and sin alpha into sin beta is equal to c square minus a square by a square plus b square. Now children, you are given with a condition, that is a cos theta plus b sin theta plus c is equal to 0. Now we can rewrite this statement as a cos theta is equal to c minus b cos theta, b sin theta. Then we will call it as equation number 1. Now we will take squaring on both sides, children. Then we will be left with a square cos square theta is equal to c square minus 2 into c into b sin theta plus b square sin square theta. Now cos square theta, we will replace it with 1 minus sin square theta, and remaining we will keep it as it is. A square into 1 minus sin square theta is equal to c square minus 2c into b sin theta plus b square sin square theta. Then we will simplify it further. We will multiply with this bracket part, totally we will multiply with a square. So a square minus a square sin square theta is equal to c square minus 2c into b sin theta plus b square sin square theta. Then we will try to get all the sin square terms to one side, and remaining we will send to the other side. Then we'll have it as, we have it as minus a square sin square theta, and if you get this b square sin square theta to this side, you will be getting minus b square sin square theta. I've taken minus common and also sin square theta common, and we have taken it as minus of a square plus b square into sin square theta. Then this is equal to minus 2c into b sin theta plus c square, and this a square we are moving to the right hand side. Then we got it as c square minus a square. Still further, we will rearrange the terms by taking minus common and getting all the terms to one side. Then we'll be getting it as a square plus b square into sin square theta minus 2bc sin theta plus c square minus a square is equal to 0. We'll call this as equation number 2. Just observe this equation 2, children. Equation 2, is it not looking like a quadratic equation? What you have learned in your class 10? Isn't it? There you have taken it as ax square plus bx plus c equal to 0 as a standard quadratic equation. Now instead of x, you have sin theta over here, right? So I can say equation 2 is representing a quadratic equation in terms of sin theta, right? Now you are given that alpha and beta are the solutions of a cos theta plus b sin theta plus c equal to 0. Now it means sin alpha and sin beta should be the solution of equation 2, isn't it? Now if sin alpha and sin beta both are the solutions of equation 2, then sum of the roots and product of the roots can be calculated directly. What is sum of the roots, children, for any quadratic equation? Alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. This is what we have learned in class 10, isn't it? So here the root, what we are defining, root or the solution, is sin alpha and sin beta. Therefore sin alpha plus sin beta is nothing but sum of the roots, and sum of the roots will be given by minus b by a. Instead of b, you have it as minus 2bc, and a value is a square plus b square over here in this equation. So sin alpha plus sin beta is equal to 2bc by a square plus b square. Then sin alpha into sin beta will be product of the roots, and product of the roots will be given by the formula c by a. Here c is what? C square minus a square, and of course a is a square plus b square. Now this is what we need to prove, right? So sum of the roots and product of the roots we have calculated for the given problem. Now the next one, express 1 minus cos theta plus sin theta by 1 plus cos theta plus sin theta in terms of tan theta by 2. Now, before we go with the solution, I just want to leave a hint to solve in solving such type of problems. Now, children, whenever you see 1 and cos theta combination with plus and minus, of course, 1 minus cos theta and 1 plus cos theta. The first thing which should come to your mind is the multiple and submultiple angles formulae, which talks about cos 2a. Cos 2a, we have totally 4 formulae what we have seen, isn't it? So we have seen a formula with the combination of cos and sine. One is purely cos and one is purely sine. Now what are they? We will look into this, children. Cos A is equal to cos square a by 2 minus sine square a by 2. Now if you have cos 2a, you know how to write, isn't it? Now if you have a, here you are taking it as half the angle. I have discussed regarding this when I was telling multiple and submultiple angles. I told you to learn only 2a formula and the remaining you can write as it is, isn't it? If you have a by 2 over here, then it becomes a by 4 in the right hand side. So cos a is cos square a by 2 minus sine square a by 2, and it can also be taken as 2 cos square a by 2 minus 1, and you can also write cos a as 1 minus 2 sine square a by 2. Now what is that which is relating these formulae with this? Now I was just mentioning, whenever you have 1 and cos theta combination with plus and minus in between, right, you need to devise a logic where you can somehow cancel 1 from the statement. That solves maximum of your problem. And how to cancel that 1? By taking one of the formulas which are involving 1 here. Now, if you have plus 1 in the problem, then you try to select a formula where you have minus 1. And if you have minus 1, then you try to get plus 1 into the problem by selecting appropriate formula from this. Right? Now, how to go with that, we will see, children. So, you have 1 minus cos theta. Now, that means I have plus 1. So, somehow I should get minus 1 into the problem by making use of the formula so that this plus 1 gets cancelled. Now, look at this. We are taking the formula for cos theta as 1 minus 2 sine square theta by 2. Why only this? Why not this? Look at this. See, when you take 1 minus 2 sine square theta by 2, this 1 when we multiply with minus, it becomes minus 1. 1 and minus 1 get cancelled. Now, suppose if you pick this formula, then you have minus 1. Minus 1 into 1, it becomes plus 1. You cannot cancel. Hope you are able to observe the concept over here. And at the same time, sine theta formula, we are taking it as 2 sine theta by 2 and cos theta by 2. Okay. Then in the denominator, since I have plus over here, I am just selecting this formula with a minus 1. So that 1 and minus 1, they get cancelled. Right. So now, when we cancel this ones in the numerator and denominator, what are we left with? Minus into minus plus 2 sine theta by 2 into now 2 sine square theta by 2 and 2 sine theta by 2 cos theta by 2. Out of this, we are taking 2 sine theta by 2 common. So that will be left with sine theta by 2 plus cos theta by 2. Likewise, in the denominator, we can take 2 cos theta by 2 common, children. Then you will have it as cos theta by 2 plus sine theta by 2. Now, just observe the bracket part in the numerator and the denominator. Then both are similar, right? Both are same. So you can very well cancel. And not only that, you can cancel 2 in the numerator and denominator also. Then what are we left with? Sine theta by 2 by cos theta by 2. Sine by cos gives you tan. So this is equal to tan theta by 2. Now what is our question? The question is, you just try to express this expression in terms of tan theta by 2. Did we get in tan theta by 2? Yes? All right. Now we'll go with the next concept, next problem. If 0 less than theta less than pi by 8. Now what is this condition telling you? Where is theta, children? What is pi by 8? Pi by 8. Is it less than 90 or more than 90? How it is? Pi is 180. 180 by 8. 180 by 8 is very much less than 90. So where is theta? Theta is in the first quadrant. Now how are the trigonometric ratios in the first quadrant? They are positive, isn't it? By ASTC property, right? So if 0 less than theta less than pi by 8, then show that root of 2 plus root 2 plus root of 2 plus 2 cos 4 theta is equal to 2 cos theta by 2. Now children, just now we were mentioning the formulae for cos 2 theta, right? So we will try to make use of that concept and we will try to solve this problem. We are just taking the LHS. Now, what is cos 2 theta, children? Cos 2 theta is nothing but 2 cos theta, 2 cos square theta minus 1. Or you can write it as 1 minus 2 sine square theta. Now, if you have cos theta, then what is that you will be taking? It will be 2 cos square theta by 2, isn't it? We are just changing the angle by making it half, because if you have 2a in the answer, you will be getting a. If you have a in the answer, it will be a by 2 and so on. Now here you have cos 4 theta. So cos 4 theta, how do you write? 2 cos square 2 theta minus 1. Look at this, 4 theta is exactly half over here, right? Now why only this formula? See, when you have plus in between, see, when you take 2 common over here, it becomes 1 plus cos 4 theta. Now, just now I was talking regarding this. When you have 1 and cos theta combination, you try to select an appropriate formula to reduce the problem as much as possible. Okay, we will try to simplify it further by making use of this. So we will have it as root of 2 plus root 2 plus root of 2 plus 2. Instead of this cos 4 theta, we will write it as 2 cos square 2 theta minus 1. Okay, then this 2, when you are multiplying with minus 1, it gives you minus 2. 2 and minus 2, they get cancelled, isn't it? Now what is left under the root? It is 2 into 2, 4 cos square 2 theta, right? So we'll have it as root of 2 plus root of 2 plus root 4 cos square 2 theta. Did you observe? We have simplified this, right? Now we can very well remove this root also by writing the square root of this. It is nothing but 2 cos 2 theta. Root of 4 is 2. Cos square 2 theta under root will be cos 2 theta, right? So you will have it as root of 2 plus root 2 plus 2 cos 2 theta. Now, when we have started with the problem, we have 3 square roots in the problem. Now we have reduced to 2, right? Now, still further to continue with root of 2 plus 2 cos theta. The same concept repeatedly we will be using, children. Now, instead of cos 2 theta, we will take it as 2 cos square theta minus 1. Then, when we substitute that in the place of cos 2 theta, here again 2 into minus 1 gives you minus 2. 2 and minus 2 they get cancelled. Then what are we left with? We are left with 4 cos square theta, right? So root of 2 plus root 4 cos square theta. Now here again we can find out the square root and we can write it as root of 2 plus 2 cos theta. Now, instead of cos theta, we can write the formula as 2 cos square theta by 2 minus 1. Hope you are observing this, children. First we have taken cos 4 theta, then cos 2 theta, then now cos theta. Now on the right hand side, first it was 2 theta in the formula, then theta, now it is theta by 2. Right? This is how we try writing the formulae for multiple and submultiple angles. Now instead of cos theta, we will substitute 2 cos square theta by 2 minus 1. Then of course 2 and 2 into minus 1, that is minus 2, they get cancelled. Then we are left with what? 4 cos square theta by 2. 4 cos square theta by 2 under root gives you 2 cos theta by 2. Therefore, we can conclude saying that root of 2 plus root 2 plus root of 2 plus 2 cos 4 theta is equal to 2 cos theta by 2. Hope you got it. I have selected this problem just for the reason that you should get acquainted with this type of formulae deduction. Okay. Now, prove that 1 by sine 10 minus root 3 by cos 10 degrees is equal to 4. Now, when you look at this problem, you will feel like we don't know what is sine 10 and cos 10. Then how to go with the problem, isn't it? Now, this is very simple, children. We will make use of all the formulae, whatever we have discussed till now, and we will try to simplify in a much easier way, which you also like it. Okay, now take LCM. You have it as sine 10 degrees and cos 10 degrees. Now, to simplify it, you will get it as cos 10 degrees minus root 3 sine 10 degrees. Now, when you look at the denominator, it is sine A cos A. If we can take 2 here, it becomes 2 sine A cos A, which looks like sine 2A formula, isn't it? Now, here in the numerator and the denominator, we will try to multiply and divide with 2. We will multiply and divide with 2. Then, in the numerator part, this 2 in the numerator we will keep as it is. 1 by 2 we will take inside. Now what happens we will see. 2 into 1 by 2 cos 10 degrees minus 1 by 2 into this term gives you root 3 by 2 sine 10. Now in the denominator, 1 by 2 we are keeping outside and this 2 in the numerator we are multiplying. So 2 sine 10 cos 10. Now, clearly in the denominator 2 sine 10 cos 10 is looking like sine 2A formula. So sine 2 into A, that is 10 degrees, sine 20 degrees. This is clear. Now let us look into the numerator part. In the numerator you have 1 by 2 cos 10 minus root 3 by 2 sine 10 degrees. Right? So here 1 by 2 and root 3 by 2 we should replace with cos and sine of some angle in such a way that we will be in a position to substitute some compound angle formula over here. Now how to go with? Now 1 by 2 half. Where do you get half, children? Sine 30 you will get and cos 60 also. At the same time, where do you get root 3 by 2? Root 3 by 2 you will get when you have sine 60 degrees and cos 30 degrees. Now, we will try to choose sine term in the numerator for a reason that you are getting sine 2A in the denominator, sine term in the denominator, so that keeping that in mind, we will also try to simplify the numerator part in terms of sine only. Then you should get it out. Why we have to take only sine term? See, observe your solution. We need to come out with. We have only a constant. You don't have any sine or cos term or any trigonometric function. Now, if we are getting some sine term in the denominator, if we can get a sine term in the numerator also, there is a chance of the terms getting cancelled. That should be your logic when you're solving the problem, right? So this is the reason why we are trying to replace this 1 by 2 with sine 30 degrees and root 3 by 2 with cos 30 degrees. When we do so, at the same time, this 1 by 2 when it goes to the numerator, it becomes 4, isn't it? It becomes 2 by 1, reciprocal of this. So 2 into 2, which gives you 4, sine 30 cos 10 minus cos 30 sine 10, which is nothing but, this is nothing but the compound angle formula, sine of A minus B. What is A and B over here, children? A is 30 and B is 10. So sine of 30 minus 10, which is nothing but sine 20 degrees. So sine 20 in the numerator and denominator, they get cancelled and you're getting the answer as 4. Okay, now we got the solution, right? Now the next problem, children, prove that sine power 4 pi by 8 plus sine power 4 3 pi by 8 plus sine power 4 5 pi by 8 plus sine power 4 7 pi by 8 is equal to 3 by 2. Now don't get scared by looking at the problem. We will try to simplify by making use of our basic concepts what we have taken up in the first session, isn't it? We have taken 90 minus theta, 90 plus theta format and also with ASTC property, right? So here, children, we will try to get 3 pi by 8, 5 pi by 8 in 7 pi and 7 pi by 8 in the simpler form, right, where we can go with some substitution. Okay, now look at this. This is your LHS, right? Now first we will go with 3 pi by 8. 3 pi by 8, we can always write it as pi by 2 minus pi by 8. Pi by 2 is 90. I am writing it as 90 minus some theta form. Okay, then 5 pi by 8, we will take it as a 90 plus pi by 8. Just check it out. The LCM, what is your LCM here? What is your LCM here? Just check it out. Simplify. You will, when you simplify, so you will get it as LCM is 8. Then you will have it as 4 pi minus pi, which is 3 pi by 8. Likewise, when you add, it will be 4 pi plus pi, which is 5 pi by 8. Now, likewise, 7 pi by 8, we will write it as pi minus pi by 8, right? Then it leaves you 7 pi by 8. Why we are taking so? See, we know the formulas for 90 plus and 90 minus theta with all the trigonometric functions. And not only that, we have 180 plus and minus, 270 plus and minus, and so on. Now, just we will try to replace this, children. Sine power 4 pi by 8 plus sine power 4 90 minus pi by 8 plus sine power 4 90 plus pi by 8 plus sine power 4 180 minus pi by 8. Okay, now first let us see sine of 90 minus theta, which is nothing but cos theta. So this term can be replaced with cos power 4 pi by 8. Likewise, 90 plus theta. Sine of 90 plus theta is cos theta again. This is in the second quadrant. Sine is positive, right? So you will be getting it as cos power 4 pi by 8. Now what is this, children? Sine of 180 minus theta form. Sine of 180 minus theta, second quadrant. Second quadrant, how is sine? It is positive. And you have 180. Therefore, you will be getting same function. That means this can be replaced with sine power 4 pi by 8 only. Okay. Now, did you observe when I was starting the session, I said we are not confining ourselves with one single formula. We will try making use of all the formulas. We are literally playing with the formulas, children, right? So sine power 4 pi by 8 plus cos power 4 pi by 8 plus cos power 4 pi by 8 plus sine power 4 pi by 8. When we simplify it, you will get it as 2 into sine power 4 pi by 8 plus cos power 4 pi by 8. We don't have any direct formula to replace this. And of course, 180 by 8 is not a standard value, right? So we will try to go ahead simplifying it further. Now, this is this terms what you are able to see in the bracket. We can always write it as sine square pi by 8 whole square and cos square pi by 8 whole square also. Now in that case it looks like a square plus b square form, right? So we can always write it as sine square pi by 8 plus cos square pi by 8 whole square minus 2 sine square pi by 8 cos square pi by 8. Now this is like a square plus b square is nothing but a plus b whole square minus 2ab form. Okay. Now, why did we do this, children? The reason is in the bracket, whatever you are getting here, it is an identity, trigonometric identity, isn't it? Sine square theta plus cos square theta equal to 1. Theta can be anything, right? So here this bracket can be replaced with 1. So you have it as 2 into 1 minus 2 sine square pi by 8 cos square pi by 8. Now multiply with 2, children. You will have it as 2 minus 4 sine square pi by 8 cos square pi by 8. Now we can always rewrite this as 2 sine pi by 8 cos pi by 8 whole square. Now 2 square is 4, isn't it? And likewise sine square and cos square terms. Now how is this bracket looking like, children? Is it not looking like your sine 2a formula? Right? Sine 2a is nothing but 2 sine a cos a. So we can always write it as sine 2 into pi by 8. 2 into pi by 8 is nothing but pi by 4. What is pi by 4? 45 degrees. 45 is, sine 45 is 1 by root 2. Therefore, we will replace it. You will have it as 2 minus 1 by 2. 1 by root 2 whole square is 1 by 2, isn't it? So you will be getting it as 3 by 2. Therefore, your solution. Now, we'll go with another important question, which will be generally given for 4 marks, children. Now, prove that cos pi by 11, cos 2 pi by 11, cos 3 pi by 11, cos 4 pi by 11, cos 5 pi by 11 is equal to 1 by 32. Now, to prove this problem, let us start taking LHS. And just for our convenience, we will name the LHS part as C. Then we will consider S. We will consider S such that we will get it as all the sine terms with the same angles. Okay, we are just taking this for our convenience, right? And C and S, we will try to multiply, children. C into S. When we multiply, just we are writing C and S, that's it, whatever we have in this above statement. Then we will rearrange the terms. We will write it as sine pi by 11 cos pi by 11, sine 2 pi by 11 and cos 2 pi by 11, sine 3 pi by 11 and cos 3 pi by 11, sine 4 pi by 11 and cos 4 pi by 11, and sine 5 pi by 11 and cos 5 pi by 11. Now children, this is a combination of sine and cos. If we can go with 2 here just beside this, then it becomes 2 sine a cos a format. I think you got your logic now, right? Now 2 we will multiply and divide with 2 in each and every bracket. In each and every bracket, we will try to multiply and divide with 2. When we do that, 1 by 2, the 2 which is there in the denominator in all the brackets, first we will pull it out. Then we will get it as 2 into 2 into 2 into 2, 5 times we are multiplying. So you will be getting it as 1 by 32. And what is happening to the numerator 2? When we multiply 2 into sine pi by 11 cos pi by 11, it looks like sine 2a formula, which is nothing but, you will be getting it as sine 2 pi by 11, isn't it? So we'll just look into this. C into, now S we will write, children. Then our first bracket, of course, 1 by 32 we will write first. As we have seen just now, this will become sine 2 pi by 11. Then here you have 2 pi already, so it becomes sine 4 pi by 11. 3 pi you have as A. Then when you apply sine to A formula, you'll get sine 6 pi by 11, and likewise sine 8 pi by 11 and sine 10 pi by 11. Now, whatever terms are common on either sides of the equality, we will try to cancel, right? Now we have sine 2 pi by 11 on either sides, they get cancelled. And what else you have? Sine 4 pi by 11 also you have, they get cancelled. Now what is that you are left with? You have c into sine pi by 11, sine 3 pi by 11, sine 5 pi by 11. You don't have the same terms over here. Now what we will do, we will try to write 6 pi, 8 pi and 10 pi by 11 in the format where you can see pi, 3 pi and 5 pi. Now how is that possible? We will look into this. 6 pi by 11. Just now when we solved the previous problem, this type of simplification we have taken up, right? 6 pi by 11 can be taken as pi minus 5 pi by 11, and also 8 pi by 11 can be taken as pi minus 3 pi by 11, and 10 pi by 11 can be taken as pi minus pi by 11, right? We will just replace 6 pi by 11, 8 pi by 11 and 10 pi by 11 in the problem with the values what we got over here. Now, your LHS is not changing. Look at the RHS part. Sine of 180 minus theta. It is sine theta only with a positive sign because it is in the second quadrant. So you have it as 1 by 32 sine 5 pi by 11, sine 3 pi by 11 and sine pi by 11. Now just look at this, children. The terms, they are getting cancelled. Are you getting the similar terms? Now when we started here, when we have taken this step, they are not similar, but we have reduced it by making use of the formula which we know, right? So C is equal to 1 by 32. What is C? C is nothing but cos pi by 11, cos 2 pi by 11, cos 3 pi by 11, cos 4 pi by 11 and cos 5 pi by 11, which is equal to 1 by 32. Right? Now, we will extensively try to make use of the formulas what we have discussed to children. So, if cos alpha is equal to 3 by 5, cos beta is equal to 5 by 13, and and alpha and beta are acute angles. There is a mention of acute angle over here. That means the angles are in the first quadrant, right? Then we have to prove that sine square alpha minus beta by 2 is equal to 1 by 65. Cos square alpha plus beta by 2 is equal to 16 by 65. Now, to start with, first we will try to make use of the values given to us. Cos alpha is equal to 3 by 5. Cos beta is equal to 5 by 13. Now, we'll go with the Pythagoras theorem application for calculation of opposite, adjacent and hypotenuse, right? When any trigonometric function is given to us, you are given that cos alpha is equal to 3 by 5. So alpha, when we take alpha as the angle, then adjacent side is 3, hypotenuse is 5. So opposite side should be 4 by making use of Pythagoras theorem. Opposite square plus adjacent square is equal to hypotenuse square. Now look at this, 16 plus 9, 25 under root will be 5, right? So you get sine alpha is equal to 4 by 5. Why so? We know sine alpha is nothing but opposite by hypotenuse, right? Then we will take beta. When we take beta, adjacent side is 5 and hypotenuse is 13. So opposite should be 12. 12 square, 144 plus 25 gives you 169, which is under, when we take square root of that, you will be left with 13. So we have sine beta is nothing but 12 by 13. Now we have calculated what is sine alpha and sine beta, right? Then we want some angle with alpha minus beta, children. So just to start with, we will calculate cos of alpha minus beta. What is cos of alpha minus beta? cos alpha cos beta plus sin alpha sin beta. Now we know all these values. Just we'll go for substitution. Instead of cos alpha cos beta and sin alpha sin beta, we'll substitute the values what we got. Then this is 15 by 65 plus 48 by 65, which is nothing but 63 by 65. Isn't it? So cos of alpha minus beta is nothing but 63 by 65. Now we don't want alpha minus beta, we want alpha minus beta by 2 angle. So we, of course, with sine square. So cos with sine, we have a formula. Cos A can be taken as 1 minus 2 sine square A by 2. So we have it as 1 minus 2 sine square alpha minus beta by 2 is equal to 63 by 65. Then by rearranging the terms, children, we will have it as 2 sine square alpha minus beta by 2 is equal to 1 minus 63 by 65. 1 minus 63 by 65, when we take LCM and simplify, you'll get 2 by 65. 2 on either sides, when you cancel, you will be left with sine square alpha minus beta by 2 is equal to 1 by 65. Now likewise, the next angle what we need to calculate is cos of alpha plus beta. Isn't it? Alpha plus beta by 2 you have. So we will consider cos of alpha plus beta, and we will go with the formula cos alpha cos beta minus sin alpha sin beta. Like what we did previously, the same thing we will go for substitution of the values, children. This is 15 by 65 minus 48 by 65, which is nothing but minus 33 by 65. Okay. Now we want cos square of alpha plus beta by 2. So we take the formula for cos in terms of cos. So you have it as 2 cos square A by 2 minus 1. This implies 2 cos square alpha plus beta by 2 minus 1 is equal to minus 33 by 65. By rearranging the terms, children, that means we are pushing this minus 1 to the other side. So you have it as 2 cos square alpha plus beta by 2, which is equal to 1 minus 33 by 65. 1 minus 33 by 65 is nothing but 32 by 65. Now, if you cancel 2 and 32 over here, you will be left with 16 by 65. Therefore, we can conclude saying cos square of alpha plus beta by 2 is equal to 16 by 65. Right? Now, having discussed extensively all these, we will try to go into sum and product of transformations. Now, what is sum and product of transformations? This is again not a new concept, children. We will just see, if you look at one formula, you will understand. Right. You have 2 sin A cos B is equal to sin of A plus B plus sin of A minus B. Now, do you know what is sin of A plus B and sin of A minus B? Yes, by this time, I'm sure you're good at this formula, right? Now, just substitute sin of A plus B and sin of A minus B formulae, automatically you will get this. Now, let us try out this, children. Sin of A plus B plus sin of A minus B. What is sin of A plus B? It is sin A cos B plus cos A sin B. And of course, sin of A minus B is sin A cos B minus cos A sin B. Now, when you do so, just cancel the common terms, whatever you have with opposite signs. Plus cos A sin B and minus cos A sin B, they get cancelled. Then what are we left with? It is 2 sin A cos B. 2 sin A cos B, isn't it? So sin of A plus B plus sin of A minus B is 2 sin A cos B. Likewise, you can also deduce 2 cos A sin B is equal to sin of A plus B minus sin of A minus B. And cos of A plus B plus cos of A minus B is 2 cos A cos B. Of course, the cos of A plus B minus cos of A minus B is minus 2 sin A sin B. You can very well try out with the second, third and fourth immediately after this class, children, then you will have that satisfaction of deducing the formula also, right? And having taken that, we have another set of formulae, that is sine C plus sine D. Now look at this formula, whatever you have. Instead of A, if you take it as C plus D by 2, and instead of B, if you take it as C minus D by 2, then it gives you A plus B equal to C and A minus B equal to D, right? Just register these words and just try it out with this formula also. Sin C plus sin D, we can take it as 2 sin C plus D by 2 cos C minus D by 2. Sin C minus sin D is equal to 2 cos C plus D by 2 cos C minus D by 2 and sin C minus D by 2. And of course, cos C plus cos D is 2 cos C plus D by 2 cos C minus D by 2, and cos C minus cos D is nothing but minus 2 sin C plus D by 2 and sin C minus D by 2. What did we do here? Instead of A, we have taken it as C plus D by 2. Instead of B, you have taken here in this formula as C minus D by 2. Then you will get A plus B as C and C plus D as A minus B as D. Then when you replace that, automatically you will get this formula, right? Now we'll make use of these formulae and we'll try to solve one problem, children. Prove that 4 cos 12 cos 48 cos 72 is equal to cos 36 degrees. Now all these terms, whatever you are seeing, they are not the standard values what we have learned, except this 72 degrees. Of course, we have seen 18, 22 and a half also, but we are not, so much acquainted with these values, isn't it? So we'll see what we can do here. Now, 4 cos 12 cos 48 cos 72 is our LHS. Instead, 4 we are splitting it as 2 into 2. So 2 into 2 cos 12 cos 48 into cos 72. Okay. Then observe this bracket part. 2 cos 12 cos 48. It is looking like 2 cos A cos B. Just now we have seen the formula as cos of A plus B into cos of A minus B is 2 cos A cos B. Therefore, we can write this bracket part as cos of 12 plus 48 plus cos of 12 minus 48 into cos 72 degrees. Of course, we are not disturbing this cos 72 degrees. Then 12 plus 48, which is 60, and 12 minus 48, which is minus 36. Cos of minus theta is nothing but cos theta. Therefore, you have it as cos 60 is 1 by 2 and this is cos of minus 36 is cos 36. We are just replacing this bracket with cos 36 and of course cos 72. Then cos 36 is root 5 plus 1 by 4. We have seen this in the previous class. And of course cos 72 is nothing but cos of 90 minus 18 degrees, which is sin 18. Sin 18, we have seen it as root 5 minus 1 by 4. These two values we will substitute in the place of cos 36 and cos 72 degrees. Then further simplifying, here in the bracket, when you solve it, your LCM is 4, then you'll have it as 2 into 2 plus root 5 plus 1 by 4 into root 5 minus 1 by 4. Now children, we will multiply these two brackets. You will have it as 2 into root 5, which is 5, minus root 5 into 1 is root 5, 3 into root 5 plus 3 root 5 minus 3 by 16. 5 minus 3, which is 2, and minus root 2 plus 3 by 3 root 5, minus root 5 plus 3 root 5 is 2 root 5. Therefore, you have it as 2 into 2 plus 2 root 5 by 16. We can take 2 common in the numerator over here, right? So when you take 2 common, it will be 1 plus root 5 by 16. Of course, 2 outside. Then this 2 and 16, when you cancel, your denominator will be only 4. That is root 5 plus 1 by 4. Just now we have seen what is root 5 plus 1 by 4. It is nothing but cos 36. Therefore, we can say 4 cos 12 cos 48 cos 72 is equal to cos 36 degrees. Right? Now, the next one. Prove that sine square alpha minus pi by 4 plus sine square alpha plus pi by 12 minus sine square alpha minus pi by 12 is equal to 1 by 2. We'll go with LHS part, children. Now here again, just observe the LHS. In the LHS, you have sine square A minus sine square B form. So sine of A plus B into sine of A minus B. A plus B and A minus B. So we'll have it as sine square A minus sine square B. Right? So instead of these two terms, we can always write it as sine of A plus B into sine of A minus B form. So sine square alpha minus pi by 4 plus sine square alpha plus pi by 12 minus sine square alpha minus pi by 12, which is your LHS. We are writing it as sine of A plus B. This A plus B. A, this total bracket is A, this is B. So we are adding them. And likewise, sine of A minus B. Now when we do so, pi by 12 and minus pi by 12, they get cancelled. Then alpha minus alpha, they get cancelled. Then we are left with what? Sine square alpha minus pi by 4 plus sine 2 alpha sine pi by 6. What is pi by 6, children? Pi by 6 is 30. Sine 30 is half. So we'll just replace sine pi by 6 with half. At the same time, sine of alpha minus pi by 4. It is sine of A minus B form. So we will expand it and of course we'll take square of that. So sine alpha cos pi by 4 minus cos alpha sine pi by 4 whole square plus 2 sine alpha cos alpha. Sine 2 alpha is 2 sine alpha cos alpha into 1 by 2. Then when we do so, cos pi by 4 is nothing but 1 by root 2. So here you have 1 by root 2 and sine pi by 4 of course is also 1 by root 2. So we can write it as sine alpha minus cos alpha by root 2 whole square plus sine alpha cos alpha. Since this 2 and 2 they get cancelled. Now we'll expand this. You'll have it as sine square alpha minus 2 sine alpha cos alpha plus cos square alpha plus 2 sine alpha cos alpha by 2. Now 2 sine alpha cos alpha with minus and plus sign, they get cancelled. Sine square alpha plus cos square alpha is our identity, trigonometric identity. So we can replace it with 1. So 1 by 2. Therefore, your LHS is equal to RHS. Now we'll go with the next problem. Now this is the application of sin C plus D and sin C minus D, cos C plus D and cos C minus D formulas what we have seen just now. You are given with sin x plus sin y is equal to pi by 4 and cos x plus cos y is equal to 1 by 3. We have to show that tan x plus y by 2 is equal to 3 by 4 and cot of x plus y is equal to 7 by 24. Okay. Now you are given with sin x plus sin y is equal to 1 by 4 children. So we'll make use of the formula sin C plus sin D, which is 2 sin C plus D by 2 and cos C minus D by 2. So we'll just apply this. We'll have it as 2 sin x plus y by 2 cos x minus y by 2 is equal to 1 by 4. We'll call it as equation number 1 and then we will take the next equation, that is cos x plus cos y is equal to 1 by 3. Then we will apply the formula. Right. Now I have misquoted the formula over here. Cos C plus cos D is 2 cos C plus D by 2 and cos C minus D by 2 children. So we will apply it as 2 cos x plus y by 2 cos x minus y by 2 is equal to 1 by 3. Right, we'll take it as equation number 2. Then equation 1 and 2 will divide one with the other. So when we take 1 divided by 2, you will have it as 2 sine x plus y by 2 cos x minus y by 2, and in the denominator you have 2 cos x plus y by 2 and cos x minus y by 2. Now the like terms, whatever you have, they get cancelled, 2 and 2, and of course cos x minus y by 2 also gets cancelled in the numerator and denominator. And this is equal to what? This is equal to 1 by 4 and divided by 1 by 3. Then what is that we are left with? Sine of x plus y by 2 by cos of x plus y by 2. Of course, this is nothing but tan of x plus y by 2. And 1 by 4, the fraction in the denominator will take the reciprocal of that. Then you will have it as 3 by 4. Therefore, tan of x plus y by 2 is equal to 3 by 4. Then we'll go with the second part of the problem. Just now we have deduced that tan of x plus y by 2 is equal to 3 by 4. So we have a formula for calculating cot from tan, isn't it? So cot A is what? Cot A is 1 by tan A. So cot of x plus y by 2 is nothing but 4 by 3, reciprocal of the value what we got here for tan. Then we have a formula for cot of x plus y, children. Cot A is nothing but cot square A minus 1 by 2 cot A. This is what we have seen in multiple and submultiple angles, right? Cot of x plus y can be taken as cot square of x plus y by 2 minus 1 by 2 cot of x plus y by 2. Then just substitute the value for cot of x plus y by 2 as 4 by 3. Then you have it as 4 by 3 whole square minus 1 by 2 into 4 by 3. Then if you simplify, it is 16 by 9 minus 1 by 8 by 3. Which is, when you take the numerator LCM and then simplify, you will have it as 7 by 9. And of course, the denominator will be taken as the reciprocal, that is 3 by 8. Now just cancel the terms possible. You will be getting it as 7 by 24. Therefore, cot of x plus y is equal to 7 by 24. Now, one more problem of similar type, children, and this is an important problem. Generally, these questions will be asked for 4 marks. Cos x plus cos y is given as 4 by 5 and cos x minus cos y is given as 2 by 7. We need to find the value of 14 tan x minus y by 2 cot x plus y by 2. We need to get the value. We are not proving it. Okay. Now, just like what we have taken previously, we will take the same thing. Cos x plus cos y is 4 by 5. So we'll apply the formula cos c plus cos d and we'll write it as 2 cos of x plus y by 2. Cos of x minus y by 2 is equal to 4 by 5. We'll call it as equation number 1, right? And the second equation, cos x minus cos y is equal to 2 by 7. We will apply cos c minus cos d formula. And we will get it as minus 2 sine x plus y by 2 sine x minus y by 2 is equal to 2 by 7. Then, as we have taken in the previous problem, we will try to take it as equation 1 by equation 2 as we have taken previously. Then we'll just write 2 cos x plus y by 2 cos of x minus y by 2 by minus 2 sine x plus y by 2 sine x minus y by 2, which is equal to 4 by 5 by 2 by 7. Now here 2 and 2, they get cancelled, children. Right? Then cos by sine is cot. So you will have it as cot of minus cot of x plus y by 2 cot of x minus y by 2 is equal to 14 by 5. Then just to rearrange the terms, you're getting it as minus 5 cot x plus y by 2 is equal to 14 tan of x minus y by 2. How this you got it as tan? This cot term, we are writing it as 1 by tan of x minus y by 2. And just go for cross multiplication. Then you will have it as 14 tan of x minus y by 2. Therefore, we can conclude that 14 tan of x minus y by 2. Send this term to the other side. It becomes plus 5 cot of x plus y by 2. And of course, on one of the sides, it will be 0. Therefore, the answer is 0. Right, children? Now here are some practice questions. You need to take this screenshot of this. I want you to practice these problems immediately after the sessions for today. Okay. Now all this, what did we do today? We have just played a game with all the formulae, right? So hope that you have enjoyed the class, and I am very sure that you will solve these problems making use of the logics which I left in today's session. Thank you.
Excellent presentation, Usha madam.
Madam, thank you.
You have given very clear and extensive explanation for every single step to solve problems. And as per research statistics, mathematics is one of the top 10 fears of students. But Usha madam, your presentation has made trigonometry easy for students to understand and apply, as I'm observing from day one. And children, this class would allow you to work out on compound angles, identity, sum and product of transformations and all. So practice n number of times to get a stronger grip on trigonometry. And it would be beneficial for your MSET, IIT and JEE exams as well if you do mastery in trigonometry. Thanks once again for the wonderful presentation, ma'am.
And I'm sure, ma'am, I'm sure after I complete this trigonometry concept, all the students from our model schools, they will shun fear of this trigonometry. I'm very sure of that.
So I felt the same. Thanks for your presentation.
Thank you, madam.